Alright, so moving on to question number 4, we're being told to differentiate sec x from first principles. So how do we solve this? We're going to let y to be equal to sec x, but remember at y, that sec x can be represented as 1 over cos x. So now, wherever there is a y, we introduce a change in y, and then wherever there is an x, we introduce a change in x. So now, making change in y the subject, this is what we end up having. So we remember that y is 1 over cos x. So we substitute that there, so we get the LCM. So the LCM right here is going to be equal to that. So this divide by that is cos x, that's why I have the cos x here, times 1 is cos x, and then this divide by that is cos x plus change in x. Multiplying that, that's what we remain with. So now we're going to open now these brackets using the knowledge of compound angles from trigonometry. Then this is what we get from the expansions. And then when you open the brackets, you can actually see that this minus sign affects this, and we have a plus sign. Then this is what we end up with at the denominator. Alright. So now there are some items that are common. So now we see cos x here and cos x here. So you can factorize out the cos x value. And that's what remains with cos x into 1 minus cos change in x. Now remember that for small angles measured in radians, sine change in x is approximately equal to change in x, and cos change in x is approximately equal to 1. So now we're going to substitute those values there, and as you can see now we are left with 1 minus 1 in those brackets. So 1 minus 1 is 0, and then we are left with that, because 0 times cos x is 0. So we're left with change in x sine x. The denominator, that's actually what we have. So now we can multiply both sides by 1 over change in x, and this is what we end up having. So now we have the slope formula, change in y over change in x. Alright, so now next I see it's actually safe to actually introduce the approximate change in x to 0. So remember that dy dx is that. So now wherever there is change in x, we put a 0, and where there is the slope formula, change in y over change in x, we're going to substitute that with the dy dx. So now we're left with sine x over cos squared x, but also remember this can be split as sine x over cos x times 1 over cos x, and then not sine x over cos x is tan x, and then 1 over cos x is sec x. So therefore the derivative of sec x is tan x sec x, and that is what they wanted.